Hi everyone, this lecture is about writing classes and methods in R. The basic idea behind writing classes and methods in R is that you want to represent new kinds of data or new data types that R doesn't kind of, by default support. So for example, if you think of a basic data type like a list, this is kind of inherent to R. There's all kinds of functions and kind of processes that you can do to lists. That's all kind of built in and comes with R. But if you can imagine thinking of a new data type, so for example, a new field emerges and they come up with their own data, this is not something that the original designers of R could have foreseen. And so you need to develop a new structure to support that data, a new set of functions to kind of apply to that kind of data type. And so that's what the idea behind writing classes and methods in R is. So anytime something new comes up, the R system can adapt and kind of support new types of data and new data structures. So that's what we're going to talk about in this lecture. The classes and methods system in R is basically a system for doing object-oriented programming. And years ago when R was first coming out, it was quite an interesting language because it was both an interactive system that supported a kind of a formal system for object orientation. And so many other languages at the time, things that had very kind of a well-known object-oriented programming infrastructure like C++ and Java were generally not considered kind of interactive languages. Those are the kinds of languages where you write programs, you compile them, and you run them, and not the kind of thing where you would type things in the command line and execute things one at a time like you do in R. So a lot of the code in R for supporting the development of classes and methods was written by John Chambers himself. So he was the creator of S and has written a lot of the code in the R system. And so the basic ideas are documented in his book, Programming with Data. And so the idea behind the class and method system in R is to kind of allow people to cross over from being a user to being a programmer. If you recall from the basic overview of the R language that I talked about in the R programming class, John Chambers' original idea for the S language was that people would start off as users, and slowly, as they became more familiar with the language, they would cross over and become programmers as they try to customize the system for themselves. So R has the same basic philosophy, where it's that people could start off as users, kind of executing functions, and then as their needs grow and as their needs kind of outgrow the R system, they could become programmers and develop new things in R, and that's the basis of classes and methods. So object-oriented programming is a little bit different in R than it is in most other languages. So if you're familiar with the language like C++ or Java, there's that is helpful, but some of the ideas in R are a little bit different. So you might want to pay attention to some of the details here. So in R, there are basically two styles of classes and methods, and this is a function of kind of historical development. There's kind of an older style, and then there's a newer style. So sometimes we'll see the older style is referred to as S3 classes and methods. So that corresponds with version 3 of the S language. And these classes and methods are informal, they're a little kludgy, and they're kind of not very formally rigorous, but they get the job done and they work quite well. And a lot of the basic functions that you use in R are kind of built on S3 classes and methods. So we know that they're already quite useful. And they're not going away anytime soon. But the more formal and rigorous system for writing classes and methods is usually referred to as the S4 system, and that became because it came with the version 4 of the S language, and it was introduced into R at version 1.4.0, which is in December of 2001. These are sometimes called new style classes and methods, and for new projects, it's generally encouraged for people to kind of use the S4 classes and methods if they're going to be developing new types of classes and methods. So these two systems for the foreseeable future will be living side by side just because of the kind of history of R and a lot of the kind of built-in functionality that's written in S3. But the S3 and the S4 systems are separate in the sense that you don't typically mix them together as you are programming new things. So the systems are fairly independent of each other. And so developers are encouraged to use the S4 style classes and methods. It's used extensively, for example, in the Bioconductor project. But the S3 classes and methods are sometimes useful because they're very quick and dirty. They're a little bit easier to program, and for kind of short-term types of projects, it may be tempting to kind of build up some S3 classes and methods in the first go. But for the most part, we'll focus on S4. I'll talk a little bit about the S3 system just so you're familiar with it, but I'll talk mostly about developing in the S4 system. So one thing that's important to know is that all of the implementation for the object-oriented system in the S4 classes and methods is implemented in the methods package. The methods package is usually loaded by default, so if you just start up R from a clean installation, the methods package will usually be loaded. But if it's not, you can always load it with the library function by calling library methods. So the basic idea in object-oriented programming in R is that you have classes and you have methods, as you may have guessed already. So a class is basically a description of something, right? And the thing will usually be some new thing, like a new data type or a new idea. And a class can be defined using the setClass method in the methods package. And then you have objects, which are instances of that class. And objects can be created using the new function, although often they can be created using other types of functions. So then a method is a function that operates on a certain class of objects. And so methods are functions that are specific to certain classes. And then finally you have a generic function, which is an R function that dispatches methods. So a generic function is usually, it tries to encapsulate a generic kind of concept, and we'll see a few of these a little bit later. For example, the plot function is one of probably the most used generic functions. And the plotting is a fairly generic concept, and how you make a plot may depend on the kind of data that you're plotting. And so there are many different plotting methods that can be applied to different data types, and the plot function's job is to look at the data types and dispatch specific methods on those different data types. So generic functions do not actually do anything. They don't do any computation. They don't do any sort of work. Their main job is to dispatch methods, and we'll talk about what that means more specifically in a second. And so a method is the implementation of a generic function for an object of a particular class. So the basic concepts are class, object, method, and generic function here. So as you're working your way through learning the system, there are a number of help files in the methods package that may come in handy. So the primary documentation are in the help file, so you can look at the classes and methods help pages. You can also look at the help pages for set class, set method, and set generic. Some of this gets very technical, so you may want to just kind of skim through it right now, but as you learn the system, it will make more sense in the future. So every object in R has a class, and the class of that object can be determined with the class function. So if I just take the number 1 here, you may recall that in R, the numbers by default are kind of real numbers or double precision numbers, and so they're considered a numeric class, and so that's what you see here. Logicals have their own class, so true and false are logicals. If you generate some random normal numbers, those are numeric. That again is a numeric vector. The missing value NA is by default a logical, but you can have missing kind of a numeric, you can have missing integer, etc. And then a character string will have the class of character. So that's all fairly straightforward. These are kind of atomic classes. But you can go beyond the atomic classes. For example, I can fit a linear model, and the output from the LM function is an LM class. So if you think about it, the output from fitting a linear model is not what you would think of as a standard data type like numeric or integer or character, but it is a data type. There are certain ideas that are kind of encapsulated from the output of a linear model if you are familiar with statistics, and so it may deserve its own data type. And so, therefore, we call it the LM data type or class. So that's the idea behind classes in R. So generics and methods are these types of functions that you'll write to implement functionality for certain types of classes. And S4 and S3 style generic functions will look different, but they are kind of conceptually the same. They play the same role. And so when you program, you can write new methods for an existing generic. So there may be a generic like plot that's already out there, and then you'll write a new method for a new type of data. But there may be new generics that you create. So you might create a new generic function for doing a new operation, and then you'll have to write the generic and the method for a given data type. So here are a few generic functions. These are S3 generic functions, and so these are probably functions that you've seen already. The mean is a generic function, and print is a generic function. And so you see when I print out these functions, there's almost no code associated with them. The only code that comes out of the mean function is this use method mean. And similarly for the print function, generic function, all you see is use method print. And so the basic idea is that these generic functions, their job is to find an appropriate method for whatever data type is being passed to them. So you can see what methods are available for the mean generic function by calling the methods function. You can see there's a mean function for dates. There's a default method, and there's one for diff time, POSIX-CT, and POSIX-LT. Now, as you kind of load packages into the R environment, those packages may add methods for the mean. So as you kind of load packages throughout your work in R, this set of methods that are available to the mean function may change over time. And so this list can grow as you add more packages. So here's an example of an S4 generic function. So this is from the methods package. It's called show, and it's the equivalent of print, but it's the S4 version. And you can see there's a lot more stuff that gets printed out when you print out the body of the show function. But the basic idea is the same. The code for show is the standard generic, and then show, and it just tries to identify the class of the object that's being passed to it, and then it will dispatch the appropriate method. And so most of the time in R, you don't call the show function or the print function because objects will be auto-printed at the command line. So here you can see what methods are associated with the show generic function, and you can see that there are a number of methods here. One is for these are all in the methods package. So you can see there's one for the envref class, there's one for functions, there's one for generic functions, etc. So all these different types of objects have a special print method or show method. So the basic mechanism by which generic functions and methods interact with each other goes as follows. So the first argument for any generic function is an object of a particular class. All right. There may be other arguments, but the first object is important. The first argument is important. And so the way the process works is that the generic function will check the class of that object. So we'll try to identify the class. The generic function will essentially do a search to see if there is a method that is specific for that class. If there is a method for that class, then it will call the method on that object, and then the generic function's job is done. The method will do the rest of the work. If there is no method for that class, then the generic will see if there's a default method, so a kind of catch-all method that always gets applied if there's no other kind of more specific type of method. If there's a default method, then the default method is called, and then it does all the work. If there's no default method, then there's an error because the generic function doesn't know what to call, and there's no default method, so it can't do anything by itself. So a lot of times you may want to look at the code for methods, but it's important to know that it's generally not possible to kind of print the code of a method function, just like you might print the code of any other function. So some functions that are not generics or methods, you can just type the name of the function in the command line, and you'll see the body of the function. You can look at the code. That's not always the case with S3 or S4 methods. And so the appropriate way to look at the code for a method is to use either the get S3 method or the get method function. So get S3 method is for S3 generics, methods, and the get method function is for S4. And the basic idea is that you pass this function. The first argument is the name of the generic, and the second argument is the class of the object.